Hey students, in this video we're going to look at some real designs of jigs and we're going to see if we can figure out what makes them good or bad. Let's get to it. Okay, so in this jig here we see that what kinds of practices do we see? The way that we look at this is that the part would go here between the black plate and the aluminum plate, and then all of these black holes here could be used for drilling. So if I were looking at this and trying to figure out what are some good design practices, a couple things that I would see. They've cleared out some big parts of the jig to try to make it lighter, and also just to make it so you can tell that the part that's underneath is in the right position. You can see it. Maybe that would be helpful in some instances. They have this attached, all of these pieces that are sticking up are places that the jig attaches to this base, this jig base. And so you can see that it is not deterministic at all. So they must be working with something that is either somewhat bendable or else just because there are so many places across here that they need to attach it and need to guide it, they're going to have to use a lot of attach points. So not deterministic in that way. Other things that we would look at to see that might be good practices on this jig, well, I see a couple of them. When they were building the jig, they put all of these cutouts in the frame so that the weld length is much shorter, and that would cause less warpage when they're welding the big black plate onto the base. Also, this jig is made to be moved around. You can see that it has fork truck holes in the bottom of the jig, and it has a weight on it so that you can know what fork truck to use when you're moving it around. If I were going to identify this, it looks to me like it's probably a plate jig. You're putting this plate in place on top of the jig and then drilling holes through it. One interesting thing is you can drill holes at all kinds of angles in here, so that was probably a pretty expensive jig to make because it would take a really large 5-axis machine to make that jig. Let's look at a much simpler jig. This is one that you could just create if you had a job where you just needed to, to make parts. This is really simple to machine and could be created very quickly. So what this is doing is you would put a nut, and in fact it can take a couple different sizes of nuts. You put them in place and then hold it in place with this screw on the side, and you can drill from the top through the edge of the nut. We'll get rid of me so you can see that a little better. And the reason to do that is because it puts a slot in the nut so that you, or maybe a hole in the nut, so that you can put a retainer that keeps the nut from spinning so that you can make sure that this doesn't come apart. So retainers like this and safety wires are used in race cars and probably boats, though I don't know. Airplanes very often, things that you can't get to that would be really, really bad if they unscrewed and the nut fell off, will have a retainer like this, a safety wire. So looking at this, what do we learn about it? Well, it's called a window fixture because it's got this hole here in the middle, but this is also a jig. It's all made of aluminum, and so it's not going to last very long. They're not going to make a lot of parts off this. There also must not be very much requirement for precision because they're using a steel drill bit in an aluminum hole, and so that's going to wander around and not be a very straight hole when it drills. You can see that they've put in relief at all of these corners, so if the nut doesn't have a razor sharp edge on it, it will still fit in the fixture, so that's a pretty neat thing that they've done. It does not position the nut forward to back in the fixture, so that must not be important to what they're trying to do. So I would say the advantages of this fixture are it was really quick and easy to make, and it does the job. It's not a very high precision job, and you're not going to get a lot of parts out of it. Okay. Next kind of fixture. So this one, what kind is it? I would say that this one is probably a U or a channel fixture. You can see that it has these edges. on it, and then the plate. It does have little blocks on the end to hold the part in place. Here's the part right here. What are some things that they've done in this design that are really good? Well, one of them is, as you drill the holes, because you drill the holes from the top, the entire bottom of the fixture is open. So all of those chips will just fall out of the way, and they're not going to get in the way of mounting the next part in there. It's not going to collect chips. They'll just fall down onto the table out of your way. One of the neat things about the top here is that they've color-coded the different size holes. So you can see some of them have red around them, one yellow, one blue. And so that helps you to know what size drill bit you should use when you're drilling those different holes. What are some downsides to this? Well, one real downside that I see with this is that there are so many screws and holes and bushings and things up here. It's not entirely clear what is to be done, and it would be easy to forget or to miss one of the holes that needed to be drilled on top, just because there are all these other things holding the box together. The color coding helps with that some, but anyway. Another thing that I think is, possibly good, possibly not. You can see down here that we can't see what's underneath it. We'd assume that there are 3 points there. You can see 2 on the end and 2 on the side and 1 on the other end. So, and 1 on that side too. So they have over-constrained where this part goes. That's not the best. They could have done that correctly so that the part would position in the right place each time, but that must mean that it's not that critical to the part. They have these clamps, which are really, really simple. You just rotate the clamp and then tighten down the Allen key. I think that's probably pretty good, but it requires another tool to be able to tighten it down. And if you unscrew this very much, then it's pretty inefficient. If you just unscrew this a half turn or something and twist the bar to the side, then it would load and unload pretty quickly. Okay, here's another one that is like the one for doing the nuts earlier. You can put a safety wire through the end of the bolt to keep the nut from coming off. This has many of the same attributes as the previous. It is now a steel piece instead of an aluminum piece, so maybe the holes will last a little bit longer. There's nothing to prevent you from putting to tell you how far to screw this in. Also, that's a little bit inefficient to have to take this bolt and thread it in some amount before you can drill and then unthread it. That's going to take a while. One really neat part of it though is, as long as you're going to do this and set it up and make it so it will do one bolt, you might as well drill a lot of bushing holes and a lot of holes for screws, and then as each one wears out, you can just move over and use the next one. This one is kind of confusing. So here is the part right here, or you can see an image of the part down here. It is not entirely clear what this jig is doing. What is entirely clear is that it is going to take a while to put the part on this jig. You have to unscrew this bolt unless there's a release on it somehow, but it looks like you have to unscrew this bolt, slide the part into the jig, and then screw this in to hold the whole cylinder in place. There are these bars on the side to center it and try to get it at just the right location, and then it looks like you're drilling a hole from the top. Possibly that is from the top, that is going to be centered in the part. And maybe you're drilling a lot of them. I don't know. It's really kind of hard to tell exactly what's going on. So what would we say about this? Well, it does have big holes on the sides and big holes on the ends for coolant and chips to fall out. It looks pretty expensive. It is a built-up jig. You can see that every place that you have 2 pieces put together, there are 2 bolts and 2 holes for pins to hold it together. And so it's a pretty high precision that they're doing here. It's a little bit hard to center something like this when you're using bolts on both sides to center something. That generally means you also have to have a way to measure it to confirm that it is right in the center, rather than having it so that you're centering on one side and clamping from the other. Now, if we're having to center it from both sides, What does that mean for us? Well, one thing is it would suggest to us that the GD&T that was called out on this part was regardless of feature size rather than MMC. So regardless of feature size, that means when we're putting this hole in, this hole has to go directly through the center of this rod, no matter what diameter this part is down here. So that often makes a more precise item, but as I said, it's a lot harder to set it up because you have to move these two screws on the side back and forth to get the part exactly centered where you want it to be. Okay, this is a tumble box jig. It could also be termed a U-channel jig, I guess. But anyway, this one has some really good design properties. So some things in it, it's easy to get the part in and out. You just bring this handle back and the lid opens and you have ready access to the part. The sides are completely open, so any chips and coolant that are used in the drilling process will just fall out of the sides. Also, it has feet underneath it, so if there are any chips on the table, it's not going to sit on those chips. So that's also a good thing. The feet will make it so that it sits evenly and applies a lot of pressure at each foot, so it's a lot less likely to slide around. Other things that I really like, this lid, because it is a cam lever on the lid, will just open and close with one motion. When you open this lid, it opens up against this stop back here, and so the lid won't flop over on the table behind this. That allows it to work in a much smaller amount of space and also optimizes the motions that the operator has to make to get the part into and out of the jig. It has these bushings up here that are replaceable, so this jig can be replaced and renewed and can continue to make parts even after the bushings start to wear. You can replace them. And then it has location dowels in here. It's a little hard to tell exactly how it's locating, but they have apparently thought of the locating process and trying to achieve determinism in their process. So I really like this one. It just has a whole lot of really good design ideas that make it really easy to use. Okay, this one also has some interesting design ideas. So this is, again, another U-channel jig. It looks like you put the part in here. It has this locking screw to tighten the part in and then close the top. This over here is a little hard to see what it is, and I tried to draw a version of it, but I'm not sure it's more clear. Anyway, this is called a quarter-turn bolt. So the way that this works, or a quarter-turn screw, is it has a head on it that can be operated by hand. You can see the side view right here. And the thing that's really cool about the head on this is that you can operate it by hand, but it's very narrow. So if you have it turned crosswise to this slot, it will hold the lid down. But from this point, if we turn it just a quarter rotation, it will line up with the slot that you can see right here, and then this lid will hinge open on this hinge over here. So generally, when we're doing design for assembly, we talk about the fact that it's only the first thread that matters on loosening, or the very last thread that matters on tightening. The other 15 are waste, and they waste time. But if you use a quarter turn screw like this, it's just a single quarter turn, and then the whole lid opens. This one has feet underneath it, so there's places for chips to fall out the bottom. There is clearance underneath. You can see that they've thought about determinism. There's a locator over here and some locators underneath. There's chip clearance in here, so if there are any chips that get inside the fixture, there's place for them to go, and then the chips can easily wash out the sides when needed. So lots of really good ideas in this one as well. Okay, here is a full tumble box jig. You can see that it's closing up most of the sides. A couple of really good things. This one also has feet, which lifts it up off the table so that chips on the table won't matter as much. It has a version of the quarter turn screw. In this one, you unscrew this handle about a quarter rotation, and then this entire screw will fall out to the side of this slot, and then the lid, which is hinged on this end, can lift up and you can replace the parts. It has a big hole open down here to help chips and coolant fall out, though there aren't very many holes in other places, so that's a bit of a challenge to it. But the reason that there aren't holes in other places is because this is has bushings to put holes in many different locations. We can't tell a whole lot else about this. One last thing that I would say here is that to me this looks very slippery and very small diameter. Now so that makes it hard to operate by hand. The good of that is that the small diameter keeps it out of the way of these drill bushings, so the drill is not going to hit it. The bad is that it makes it a lot harder to grab and to turn to open it up. Here is another version. This is a 3D printed version where somebody was going to make it, but you can see just like this one, this has a hand wheel on top. You rotate the hand wheel just a little bit and then the screw falls out to the side and you can open the lid, which is pivoted over here. So that's kind of good, but you can see the problem with this. There's a bushing right there and this handle is very close by, so it takes a longer drill bit to be able to drill in this bushing without hitting the handle. This one has very good clearance on the sides. It has clearance underneath that give it feet, and so chips will come out. Chips underneath won't matter so much. Lots of good things in this design also. Okay. One thing that I want to talk about is that we are talking in this about boring jigs, which are not boring, but they are for the process of boring, but that is different than a jig borer. This is a jig boring machine or a jig borer, and you can see that it's kind of the same idea. It is a machine, and so you would put the boring bar on this end, it would feed through the part, this bearing on the other end you would raise to the right location, and it supports both ends of the boring bar so that you can get a very precise hole bored through the part, and this will keep that big boring bar from drooping any. So it's kind of like a CNC boring jig. And so this is very good for high precision, but it is not a simple, inexpensive tool to use, which is the point of jigs. This is a big CNC machine, very expensive, and they are great for what they do. But wanted to clear that up, that boring jigs are not the same as jig borers. Okay, that seems good. In the next video, no, there is no next video. In class, we will practice designing jigs. So I look forward to seeing you there. Bye.